Hello everyone, it's the 16th of October, which means it's time for the 16th October Leetcode challenge. Let's get straight into it. It's called Search a 2D Matrix. Write an efficient algorithm that searches for a value in an m times n matrix. This matrix has the following properties. Integers in each row are sorted from left to right. The first integer of each row is greater than the last integer of the previous row. Okay, so basically this means that the entire matrix is sorted, like top left is the smallest element, bottom right is the largest element. It's a matrix, not a square, so that's important, I guess. And I mean, it looks pretty straightforward, but I'm probably not going to do the optimal solution. I'm just going to explain a couple of solutions here first. So let's take some examples. Okay, so what's the easiest possible way to do it? Like the easiest possible way, if we don't have to write an efficient algorithm, would be to just go through every single element. So like go from the top left element and just go element by element and follow them until you either find your target or you end up on an element that's higher than your target, which means it can never be solved from there on. And what's the time complexity of that? Time complexity would be so search linearly. Usually linear search is big O of n, since we have to go through every element, but since this is a 2D matrix, then it's basically big O of m multiplied by n. So the number of rows multiplied by the number of columns. So this would be the easiest solution. Then I mean, obviously, just looking at anything sorted, your mind should be screaming binary search. So I'm pretty sure there is a way to do binary search here. So there should be a way to do binary search, which would be big O of let's see how we can binary search though. There should be an efficient way to do it. So like my instinct would be to do something like take the middle row and then just check the rows, right? So do binary search on the rows, and then which row do we have to find? So let's say we're looking for number 16. We're looking for number 16. If I start from 10, so 16 is larger than 10, then I can do binary search on the rows to the next, like the next rows, which would be 23. I need to find, by using binary search, the row that is the first row that has a number higher than the number we're looking for. So in this case, this will be 23. And if I find this row that the previous one is less than the number I'm looking for, the next one is more than the number I'm looking for, then I can do binary search in the previous row that I have already found. So in this case, I'll start here, then end up here, so like 2 iterations. Then I would start here, let's say on the 11, and then end up here in 4 goals. So that would be log of m, like on the second, log of m, and then it's actually not multiplied, it's just combined. So log of n. Why would it be combined? Because we are doing a single binary search on the columns and then a single binary search on the row. So I think this would be the optimal solution. Like there might be some very weird way to optimize if you're taking into account like some weird diagonal matrix mathematics stuff that I'm not really familiar with. But I think this should be like the optimal runtime complexity. And while it would be amazing if we could write that, I'm probably not gonna do it. I'm just going for a solution today because it's very late and I'd prefer to not spend a lot of time on this task debugging off by one exceptions like I did last time we did binary search. But you can basically do the same binary search just twice and end up with this solution. And let's try to find something in the middle that could also work. So how can we use the fact that we have both rows and columns sorted? Can we create something that's like big O of m plus n? So I'm thinking either to just use diagonals, but diagonals, they're kind of weird in oddly shaped matrices. Because for example, let's say we have 2 columns and then 2000 rows. How do we do the diagonal there? It would be pretty inefficient. But what if we start like from top right corner, right? So we start from the 7. We're looking for 16. So let's say every time our number is smaller than the number we're looking for, then we can jump an entire row down. And if the number we're currently at is larger than the number we're looking for, then we just go to the left. So this would mean that we would take at most, like if we're looking for, let's say 34 or 23, at most we would do m times, like the number of rows, iterations down, and then at the most a number of columns iterations to the left. So this would be 1, 2, 3, 4, 5. So I mean, this is not the best algorithm. Binary search is better, but I think this algorithm would be very easy to code and still decent. So let's go for that. Okay, so this is what I'm gonna write. Let's create the class. It's the 16th, right? I guess, yeah, it's the 17th in Bulgaria, so gets a little bit confusing. Thankfully, we're using some USA times. And I did create 17. Damn it. 16. And take the boilerplate. Okay. So this is the algorithm we want to do. Start from the top right corner. What is the top right corner? So top right corner is just need to keep a row and column somewhere, like maybe like that. Row equals 0, and then col equals I should have somewhere the number of rows. So number of columns is matrix 0 dot size. I'm pretty sure that matrix is regular, so we don't need to. It's not jagged matrix, so we don't need to care about that. Like matrices don't become jagged, so we can take it as a constant, the number of columns, and rows is matrix dot size. And in order to be even able to do that, I need to probably first guarantee that matrix is not null. Since this is Kotlin, it's guaranteed to not be null. And matrix size, if matrix size is 0, like return false. Like if it's empty, then whatever we're looking for, it's not there. So after that, we have number of rows, number of columns. So we start from row 0, and we start from column matrix. Oh, actually, this is size. I guess just cost -1, since this would be out of bound on its own. And now we just say I'm not sure what the condition should be, so I'll just say like wow, true, and then we'll fix it up. So we start from here, and our comparison would be if the current element is bigger than the target, then go to the left. If matrix row col is bigger than, I guess I can even extract that as a variable, so that would be current. If current is bigger than target, then this would mean go left. So going left means cos equals cos -1. co equals co minus 1. Okay, and maybe I should have checked first if it's the target. So if current equals target, then return true, because we found it. We're just checking if it's contained there, right? Searches for a value. Yeah, it's just check if it's contained. We don't need to return the indices where it's contained, which would be trivial from this point. So we check this first. Then if it's bigger, we say this. Otherwise, we say row minus equals 1. So we're plus equals 1, since we're incrementing rows. So if we're starting from 7 and looking for 23, we go down, because 20, then again 20 is less than 23, we go down. 60 is more, we go to the left. 34 is more, we go to the left. So that's all. And basically our while loop would be while we're within bounds, right? So we should never get out of bound. So this would mean while since we're only going down and left, so since we're going left, we need to make sure co is bigger than or equal to 0 and row is less than or equal to the last row, which would be rows minus 1. And if this does not return true, then we return false. So this should be like the entire thing. I'm just gonna go ahead and try it out here. Hopefully we don't have an off by 1 somewhere. I specifically took this so we don't get off by 1s. Alright, amazing. It's accepted. Okay, so it's not the best solution. As I mentioned, we can definitely improve it to have a better runtime. So instead of taking the entire m, we can take a logarithm of log m, which should be quite a bit faster. Let's just check the other solutions. I'm pretty sure that this is probably similar, but the first one sounds promising. Don't treat it as a matrix, treat it as a sorted list. What does he mean? Use binary search. I mean, obviously. You can turn it into an array converted, blah blah, whatever. Is he actually converting it to an array? I really dislike how people keep using these one letter variables, by the way. It's so hard to follow, like n, m, l, r. What the f is all of this? So yeah, he's doing binary search pretty much. This one has at least a bit better names. Start, rows, goes, end, start list. I guess the binary search is not that big. Not that much code to write. But this is something I would never want to write like from scratch on my own. Just every time I do it, I end up with off by 1 errors everywhere. But yeah, I think this is the optimal solution. There should never, I don't think it's possible to have a better solution. But yeah, that's all for today. Thank you for watching this 16th video, and see you all tomorrow.